Do I not have it? Oh, okay, well, maybe I'll go back. That's okay. In on wrapping up this unit, and just give me 1 second. So this handout, if you didn't, it means somebody didn't pass it along to you. I'm not sure why I didn't put it in the book. Maybe because it's kind of a review. And I have to figure out where I put them. There they are. There we go. Ah, yes. All right. So we are wrapping up this unit. We're going to be doing a little bit of review of concepts over the next day or two, and then I'll give you some review, and then we'll have our test. Now, of course, you remember what is happening on Monday. You have a quiz on what? The dots and crosses. So I will give you a little bit of time today to do a little bit of practice on that, okay? You should be feeling not too bad about it, I hope, but I do have some extra stuff if you need it. I would like our test, yes. You do not need to memorize the names, okay? For ionic compounds, you should be able to name them because you just name the metal and then you name the non-metal and change the ending to "ide." For the covalent compounds, there are, I think, only 3 that had a single black diamond. And those were HCl, NH3, and CH4. So if you're choosing to do the enriched material, you should know that HCl stands for, anyone know? Hydrochloric acid. NH3 stands for ammonia. And CH4 stands for methane. But if you don't want to learn those, that is totally optional. Any of the names that had double black diamond names, those were just for interest, and I don't expect you to know them at all, okay? Okay, so those are the only three you would need to know for covalent names. You would need to know for ionic names, okay, because ionic, just the metal name and the non-metal name with "ide." I'll give you a minute before I flip over somewhere else. Oh, and you should be able to name water, but yeah. For regular, actually, we should put this, you should be able to name CO2, H2O, because those are so common. Do you know what I mean? What is the name of CO2? Carbon dioxide. Oh, I'm sorry. Yeah, you're like, hang on. Dioxide. And H2O is water, of course. Okay. So this is I would like your test to be next Thursday. Does that work for you? So I'll send you home with a little bit of review this weekend, and then we'll have some review next week as well. Does that sound good? Okay. And a text next Thursday, that is November the 24th, I believe, 24th. All of Unit 3. Yeah. Yes. Yes. There we go. That should have everything on it now. Yes. Did you guys get your last test back? Yes, we did. If you haven't seen yours yet, just come and see me towards the end of class and I'll get it back to you. We did? Yes, we did. Yeah. And in fact, while you guys are copying that down, I could also give you this, which is like a vocab list for the entire unit. Would that be as helpful as you take while we do it with exam? Okay, 1, 2, 3. There you go. 1. Probably more than you need, so I'll come back and get some. so much. So one of the reasons I arranged the vocab with the word on the left and the definition and picture on the right is so that you can cover it up one way or the other and see if you can, come up with a definition or a picture, or look at the picture and the definition and come up with the word, okay? How likely do you think it is I will have you write a definition? Not particularly likely. I want you to be able to recognize things, name them, understand what they're made of, okay? So that is what we're doing there. All right. So today we're going to look at this extra review. So this is the extra handout. Is there anyone who did not get it? Anyone who came in just a moment ago? Maybe like Daria. I'm guessing. Where did I put them? Uh-oh. Uh-oh. What have I done with them? Oh, here they are. So here we have 4 types of particles. Atoms, obviously, just a circle, yes? Molecules. We have atoms, but they are what? Connected. They are bonded together. What kind of elements make a molecule? What kind of elements make a molecule? Nonmetals only. Okay, so you've got H, which is a nonmetal, O, which is a nonmetal. We have ions, and you can recognize an ion by the fact that it has a charge. But there's another type of particle where you will also see a charge. But you won't see a single charge, you'll see 2 charges. So if we look at our formula unit, it's got a positive and a negative, and it is made of what kind of elements usually? Metal plus nonmetal, yeah. Cation plus anion. Positive plus negative. So out of these 4 particles, who are the only ones that actually have a net charge? I'm going to wait till you guys are finished writing before I ask that. So give you a minute to do that. And I'll ask again. Oh, by the way, over in our molecule, we have these atoms which are bonded together. What type of bond is that? That is a covalent bond, so they are covalently in a molecule. Yes. The ones that would be compounds, formula units are always compounds because it's always a metal and a non-metal, so you've got two different elements. Molecules have a choice of either being a compound or an element if you have two atoms bonded together the same. Okay, so formula units will always be compounds. Sorry, what's that? The OH ion is called the hydroxide ion. And in our next unit, we're going to learn about polyatomic ions, poly meaning many. And they are ions which are bonded together. The atoms are bonded together covalently, but overall, there's like one extra electron or two extra electrons on the whole structure. And so it forms an ion. Yeah? Okay. I didn't quite catch all of that. Is that all right? Okay, cool. Now, a molecule can either be a compound or an element. An element, an element. So formula units are always compounds. Non-metals, or sorry, molecules are either a compound or an element. Ions can't exist on their own. You can't have just a positive hanging around without another negative somewhere. Okay, and we have now, we're going to go a little bit into depth on each of these. Atoms are neutral. What does it mean to be neutral? No charge. The charge is equal to 0. They are the smallest component of an element, and you can either have metals or non-metals. We're not going to worry about metalloids right now. We're just going to say everything to the left of the staircase is metal, or yeah, and everything to the right of the staircase is a non-metal. Not a gas. No, carbon's not a gas. You're writing with it with your pencil, right? Not a gas. Okay. Metalloids we'll deal with in our next unit. Now, if we look at how metals exist at room temperature, you would see all of the atoms, because remember, metals, what are they like at room temperature? They are mostly solids, except for mercury, that's a liquid. So they just kind of hang out in these, they're actually crystal structures. So these would be metallic crystal lattices. Okay, I don't expect you to really know that term, but I'll write it down. I'll just put like a little doodad here to double diamond. These are metallic crystal lattices. And if you're like, well, what's holding them together? It's not covalent bonds. It's not ionic bonds. These guys are actually held together by, and again, I'll put a double diamond here because it won't be on the test. Okay. They are held together by metallic bonds, which we will talk about when we get to our electricity unit. And here would be our exception. Mercury is a liquid at room temperature. How can I tell that this is a solid and this is a liquid? Yes. Yeah, this is taking on the shape of its container. It's all random, it's disorganized, whereas the solid, if I were to put it in here, it would not fit the shape of its container. It would hold its own shape, and it's very organized and regular. Nonmetals, if you remember, what states are nonmetals? Nonmetals are solids, liquids, and gases. Who's the only liquid? Bromine, okay? So this here would be a noble gas, because the other ones that are gases are not monatomic. What does mono mean? Di means two, mono means one. So these are monatomic because they are made of one atom. Can you remember the diatomic elements? See if you can remember for yourself. Who are the diatomic elements? Feel free to use your periodic table. Leon, did you want to tell us? It's all good. No worries. Take your time. It's the Brinkelhoff thing. Yes. Absolutely. Brinkelhoff. And what does Brinkelhoff stand for? We have bromine, iodine, nitrogen, chlorine, hydrogen. I'm running out of room. Hydrogen, oxygen, and fluorine. I'm sorry, that's like so messy and horrible, but they are listed for you elsewhere. So I'm just actually going to erase that because it's so messy, it's really irritating me. Okay. So if you forget who the diatomic elements are, who can tell you? Dr. Brinkelhoff. What if you don't like Dr. Brinkelhoff? What are some other ways you can remember it? The hockey stick. Where do you start your hockey stick? You can either start down iodine. I like to start at number 7 because there are 7 of the diatomic elements. So I start at atomic number 7, which is nitrogen, and I draw a 7. There's my hockey stick. Where's the puck? Way over there. What's the third way you can remember? Let's forget that last one because like nobody seems to remember it anyway. And like I said, it does tend to do things like have people think that carbon or cobalt are the diatomics, and they're not. It's chlorine. So I think Brinkelhoff or the hockey stick and puck are actually better for remembering. Okay. Now, molecules. Molecules are also neutral. What does it mean to be neutral? No charge. The charge is equal to 0. Molecules are made of nonmetals only. You have to have 2 or more atoms. You have to have the atoms being bonded covalently. What does it mean to be bonded covalently? That means you're sharing electrons. But a lot of people think that all molecules have to be compounds. That's not true. Some molecules can be elements, or we could have some molecules that are compounds. So there's a bunch of examples that we have down here so you can see both types. Okay? All of the ones on the left are molecules of elements. We have I2, that's one of your diatomic elements. What does di stand for? 2. Phosphorus has a tendency to form P4, which is like even this little pyramid structure, which is kind of cool. Okay, you don't see things like that very often. Sulfur tends to form an 8-atom ring that looks a bit like a crown. Okay, and usually sulfur is represented as yellow, so it's even like looks like a gold crown. We have oxygen, which is O2. That is another diatomic element. And what do those 2 lines in between mean? There are 2 pairs, yeah, and we call that a double bond. And all of those are molecules, but all of them are elements. These particular models, we draw the atoms as like just a ball, okay, or a sphere. And then we draw sticks in between. So these models are called a ball and stick model. And they're really useful because you can be like, oh, this one's bonded to that one. It's really easy to see. We can also have molecules which are compounds. So over on the right here, you can see we've got H's and O's. We've got C and H. And we have, oh boy, what on earth is that thing? We have carbon and hydrogen and oxygen and nitrogen. And I believe, I could be wrong, but I believe this is caffeine. Not that you're responsible for that, but that's just for fun. And if you were to go around in here and count, you would see that little 2 beside the O? What does that tell you? There's 2 O's, and look at that. Oh, the O's are red and we can see them there. And actually, this is wrong. That should be N4. So let's cross that out and correct that. That should be N4. That little star is going to remind me to make that change for next year. And we can count our carbons, which are the big black ones. 1, 2, 3, 4, 5, 6, 7, 8. We got that one right. And then the hydrogens, 3, 6, 9, 10. does anyone remember what CH4 is called? Methane. And of course we have H2O, which is water. But they're all molecules because all of the atoms in there are what type? They're all nonmetals. So we have the ball and stick model, but we can also show them as a space-filling model. This is more accurate, but it's also harder to distinguish individual atoms. Like it's kind of like, you know, you look at this, they kind of look all mushed together, and it's harder to see the atoms. Okay, but so these are space-filling models here. Ions have an electrical charge, which means the charge does not equal 0. It's going to be positive or negative. It's either lost or gained electrons. What does it mean to be monatomic? 1. Poly means many. So a polyatomic ion has many atoms bonded together, so we can say 2 or more. And of course, hopefully by this point it should be like becoming second nature that cations are positive and anions are negative. What kind of element form cations? Metals. Metals form cations. Okay, so the metals are the cations. What kind of elements form anions? Nonmetals form anions. And then there are both polyatomic cations and anions. In our next unit, you will get a chart that tells you the identity and the name of all of those. If you have trouble remembering, of course, here's our cute little cat. Cats have paws, so cations are positive. Negative ion, anions are negative, or onions make you cry, which is negative. I was just so happy to find a crying onion. Like, it made me so happy I had to stick it in there. So here we have a monatomic, 1 atom, metal cation. Okay, we have sodium plus, Na plus. We have Mg2 plus. You can either show the positive charge inside the circle or outside the circle. It doesn't really matter. Just depends where I'm grabbing my images from. And we have monatomic, so 1 atom, nonmetal anions. And again, the charge can either go inside or outside of the circle. Here is a polyatomic cation. Do you remember what NH3 was? NH3 is ammonia. We have a polyatomic ion, which isn't NH3, it is NH4. And this entire structure that's made of a nitrogen and 4 hydrogens, somewhere along the way, one of those atoms lost an electron, and that whole structure is just missing 1 electron, okay, from the overall structure. You don't really need to understand that. You just be like, okay, I have this little structure, and all together it has a positive charge. And that's, again, why we put those big brackets around it, to show that the entire thing has a positive charge. Here is a polyatomic anion. It's called hydroxide. Okay, and so again, that O and that H together, somewhere along the way, an extra electron went on there, and that's why it has a -1 charge. Another example, chlorite, ClO2. You can see we have one chlorine. So there's Cl with no little number. What are those little numbers called? Subscript. So there's no subscript, because there's just one. Why can I not make this finish writing? There we go. One chlorine. And there are how many oxygens? Two oxygens. And then, of course, we have the one negative charge. And then mercury is a funny little one. This is called the mercury 1 ion. We'll get into why we have that later, but the 1 tells us that the charge of a single mercury is, what does the Roman numeral 1 stand for? 1. I should have said I, because when I said 1, of course it stands for 1. Oh, sorry, that was me being silly. Okay, so 1 plus. See how each mercury has a 1 plus? That's why it's called mercury 1. There's actually a version of mercury that has a 2 plus charge. It's an Hg with a 2 plus, and that's called mercury 2. Now, how much of this do you need to know for this test? Not at all. Okay, so I'm going to double black diamond those. Okay. But you'll see them a lot in the next unit, so it'll be nice to say, oh, hey, I've seen a Roman numeral before, right? Your brain will be like, oh, that's not completely new and different. And it means the charge. Formula units. What kind of compounds have formula units? Metals and nonmetals. Metal plus non-metal. What kind of bonds? Are you on your phone, Leon? What kind of bonds do we have? Ionic bonds. Okay, so they don't exist in isolation. It would just look like this. You would have a plus attached to a minus, but they really don't exist like that at all. They are always part of a larger structure. What is the larger structure? Yep. So here is our ionic crystal lattice. You will never be expected to draw a three-dimensional crystal lattice. I can't draw one very well. I don't expect you to be able to draw one. Some of you could probably do a beautiful job, but it's not an expectation, okay? You should be able to draw a 2D crystal lattice. Yes. Yes. How's that? There we go. You should be able to draw a 2D crystal lattice, and you should be able to draw a formula unit, okay? This little next bit, this is usually more for my grade 11s. I expect my grade 11s to be able to recognize that if you have this alternating pattern, even if it's not labeled plus minus, plus minus, plus minus, you should be able to recognize that this is a pure substance, not a mixture. Okay, I'm going to double diamond this one. It's an ionic compound, and it is a crystal lattice. But like I said, I think that's maybe a bit sophisticated for grade 9, like to be able to go past the point where we've labeled the positives and negatives for you and to just be able to imply that there are positives and negatives there because you can see that they are alternating, you know, A, B, A, B. There's no randomness in that at all, okay? But don't you worry about doing that. It's because I'm too lazy to make changes to the document for my grade 9s and my grade 11s. It's so funny. They're actually doing stuff that you did already. They just wrote the same quizzes you wrote. It makes me laugh. Anyway, so here we are. And we have some questions. So if you would like to, you can work on those questions there. Folks, you'll probably be able to get close to finished this. And then for homework, there's going to be review on dot and cross diagrams. Okay, so that's what this is, because your quiz on that is on Monday. If you're planning on doing the enriched part of the quiz, you'll also want to do page 104, number 11 to 17. If not, you can skip that. No,